Okay, in this section we're still going to be looking at multi-step equations, but there is one thing that I did not go over with you guys whenever we went over this on Wednesday in class, and that is the possibility that an equation does not have a solution at all. So, for example, let's start with a really simple example here. Let's do x plus 2 equals x. Okay, so this is an equation, and if you just think about plugging in numbers, you can plug in any number here, 1, 2, 7, 5, 15, any number, and if you add 2 to it, it's not going to equal x anymore. So if we think about solving this, we've got an x and an x here. I'm going to move this x because if I move this one, there's nothing left over here. So I could subtract the x from both sides. So this would cancel like I want it to. However, the problem right here is x minus x also cancels. There has to be something here. So x minus x is 0 right there. Now, what we're left with here is just 2 equals 0. There's no x there. And so when this happens, it means that we have one of two things that are happening here. When the x's cancel out completely, we either have a situation where we have no solution or we have infinitely many solutions. So you can see here that 2 does not equal 0. If this is a true statement, if it said 2 equals 2, then we would call that infinitely many solutions. But 2 does not equal 0, so we call this no solution. Okay, let's continue on to another example. So here we've got 4 times x plus 5 equals 20 plus 2x plus 2x. So if we're going to solve this, the first thing we would do is distribute here. So I would have 4x plus 20 equals 20 plus, and I'm going to go ahead and combine these two x's right here. 2x plus 2x is going to give me 4x. And so I need to get these x's together. So I'm going to move this 4x and subtract it. But 4x minus 4x also cancels on this left-hand side. So that just leaves us with 20 equals 20. And so 20 equals 20 is a true statement. So what this tells us is that we have infinitely many solutions. Right there. And so infinitely many solutions means that any number will work. I'm just going to show you that any number works here. 4 times 1 plus 5 equals 20 plus 2 times 1 plus 2 times 1. So if I check this, 1 plus 5 is 6, so 4 times 6 is 24. Over here, this would be 20 plus 2 plus 2, and 20 plus 2 plus 2 is also 24, so that equation is the same on both sides. But I just picked 1 to plug in. What if I picked another number? What if I picked negative 2? So if I put negative 2 plus 5 equals 20 plus 2 times negative 2 plus 2 times negative 2, so this time I'm plugging in negative 2. I'll have 4 times 3 equals 20 minus 4 minus 4. 4 times 3 is 12. 20 minus 4 is 16. And if I subtract 4 again, that's also going to give me 12. And so negative 2 works. I could even pick a number like 100. If I do 4 times 100 plus 5 equals 20 plus 2 times 100 plus 2 times 100, I would have 4 times 105 equals 20 plus 200 plus 200. And if you multiply 4 times 105, you're going to get 420. And over here, if you add 20 plus 200 plus 200, you're also going to get 420. So infinitely many solutions means you can plug in any number and it will give you it'll work in the equation. We also have a special word we use for equations that look like this, and we would say this equation is an identity. Okay, so this equation is an identity, and the identity just means that whenever you put a number into this equation, it gives you that same thing out. Nothing changes there. So this equation is an identity. Let's continue on. Let's do another problem. Example 3. We're going to do 5x plus 7 equals 3x plus 7. Okay, so let's solve this equation. We need to get the x's by themselves, so I'm going to subtract this 3x from the side, which means I also need to subtract the 3x from the other side. 5x minus 3x is 2x. I'm going to bring down that plus 7 and have a 7 over here. Now I'm trying to get that x right there by itself, so I'm going to subtract 7. And whenever I subtract 7, the 7's cancel over here. The 7's also cancel over here. Now, you have to have something on either side of the equal sign. 7 minus 7 is 0, so I'm going to put a 0 right here. And the 2x is left here. Now, a lot of students will stop right here and say that this equation has no solution. But that is not true, because our x's did not cancel out here. I still have that x. 0 is a number, and we have to remember that 0 can be your answer. So if you divide both sides by 2 here, 0 divided by 2 is 0. So 0 is the answer. If you plug 0 back in, 5 times 0 plus 7 would be 7. 3 times 0 plus 7 would be 7. 0 is the answer for this problem. Okay. Let's look at example 4. We're going to have 15 minus 3x plus 2 equals 4x minus 3 minus x here. No, let's make that negative right there and positive right here. There we go. Alright, so if we're going to solve this equation right here, the first thing that we're going to have to do is we've got to distribute this little negative right here. So we're going to distribute that negative, and so we'll have 15 minus 3x minus 2. And then over on this side, I could combine this negative 4x and this positive x, which would give me negative 3x minus 3. Now on the left-hand side, I want to go ahead and combine this 15 and this negative 2. So over here on the left-hand side, I'll have 3x plus 13, and that's going to equal negative 3x minus 3. Now, when you're solving these problems, when we're kind of looking for some patterns here, we can see here that we've got negative 3x on one side and also negative 3x on the other side. We have combined everything that we can combine. Well, if I add this 3x like I would to combine these, also add the 3x here, and so I can see that those are going to cancel. So if you notice you have the exact, if you've already distributed and combined, and you notice you have that exact same variable term with the same sign on both sides, they're going to cancel out when you try to move the variables so that they're together. So if you see this happening, you can automatically look and say, oh, I got 13 and negative 3. Those are not equal to each other. 13 does not equal negative 3. And since 13 does not equal negative 3, we would say that this equation has no solution. Let's try another one. Okay, so for example 5, we are going to do 4x plus 8 all divided by 2 equals 4 plus 2x. Now this is a little bit of a weird equation. So you've got this 4x plus 8 is divided by 2, and we can't really do anything while we've got that 2 right there. So there's actually a couple ways you can deal with it, but this is what I'm going to do. Since this side is divided by 2, I'm going to multiply both sides by 2. And when you multiply both sides by 2, this is going to cancel here. We'll have 4x plus 8 on the left-hand side. When you multiply by 2, you've got to distribute that 2. You have to multiply everything on that by 2. So I'll get 8 plus 2x. I'm sorry, no, what? 2 times 2 is 4. So I'll get 8 plus 4x. And so whenever you have this, notice that both sides are the same. You got 4x plus 8 here, you got 8 plus 4x here, but of course we know that addition is commutative, meaning that the order doesn't matter, so I could write this as 4x plus 8. So these two sides match exactly. Whenever you notice that two sides match exactly, you know the answer is going to be infinitely many solutions. So if we wanted to continue, we could here. We could subtract 4x, we could subtract 4x. It cancels on both sides. 8 equals 8. 8 does always equal 8, so this one is infinitely many solutions. Okay. I also want to look at your IXL that you're going to have for just a moment. So let's look at your IXL. You will be doing J8 for me today. And so these are the type of questions you're going to have for IXL. And I'm going to make this so I can see both what I'm writing and my IXL problem. So I've got 7 equals 7b minus 8. 7b equals 7b minus 8. And so I'm supposed to solve this equation to tell if it's got one solution, no solution, or infinitely many solutions. So if I were to subtract this 7b from both sides right here, they cancel on both sides, and I'm left with x equals negative 8. I'm sorry, 0 equals negative 8. 0 does not equal negative 8. That is false. So this one would be no solution. Okay, here is another example. I've got negative 3w equals negative 5 minus 2w. So if I'm going to solve this, I would move one of these w's. I'm going to choose to add that 2w over here to the left-hand side. And negative 3 plus 2 is negative 1, so I'm going to get negative w equals negative 5. And then to get rid of that negative, I could divide both sides by negative 1, and w equals 5. Now this is a solution. You have one single solution. 5 is the only solution that you have. So if you've got a problem where you can get a number for your answer, you have one solution. So that's what we're going to choose here. Okay. Now as you do these problems, you can kind of start to see, over here I've got a negative 9t and a negative 9t. Well, whenever I have that, I'm going to add 9t to both sides, and those are going to cancel out. Let me write that down so you can see what I'm talking about here. So if you add that 9t and add that 9t, cancels on both sides. So I'm just left with negative 3 equals nothing over here, so that is 0. So you can kind of start doing these in your head where you see you've got that negative 9t and a negative 9t, and you can just cancel those out, and you just have negative 3 equals nothing, negative 3 equals 0, which is false, so this one is no solution. Now, eventually, IXL is going to start asking you if an equation is an identity. An identity is an equation that has infinitely many solutions. So if I look at this equation, negative 1 minus 6p equals negative 7p plus 9. If I add that 6p over here to the other side, I would have negative 1 equals negative 1p plus 9. I could subtract that 9 from both sides, so I'd get negative 10 equals negative 1p, divided by negative 1, and 10 is my p. That is an answer. So if an equation has an answer, then it has one solution. It is not an identity. You're only going to have an identity whenever you have infinitely many solutions. So this one would be a no. Okay. Here is another problem that asks us if an equation is an identity. And so we've got negative k plus 6 equals 6 minus k. And you can see you've got that negative k over here on the left side and also a negative k on the right side. So when you add that k to both sides, those are going to cancel out. Now you can see we're left with a 6 on the left and a 6 on the right. So 6 equals 6. This is true always. And that means that we do have an identity here. Our answer would be infinitely many solutions, which means the equation is an identity. So we put yes for this one. Okay. As you work, you can kind of start to see the shortcuts that you can take here. For example, for this problem, negative 7 minus 8t equals 7 minus 8t minus 8. And so when you see that negative 8t and the negative 8t on both sides, those are going to cancel out. And so that is going to leave you with the negative 7 over here, and then 7 minus 8 is negative 1. Those two are not equal to each other, so that would be a no solution for that. So you're going to work through these problems for me. Actually, let's do this next one because it's a little bit different. You've got 9f equals 5f plus 4f. And so over here we would want to combine these terms, and that would give us 9f equals 9f. And 9f, of course, always equals 9f. It's going to equal because both sides are the same here. So you could probably go ahead and say infinitely many solutions. Or maybe you go ahead and try to subtract that 9f. And so if these cancel, 9f minus 9f is 0. If everything cancels out on that side, then you're going to have something there. So think of 9f minus 9f equals 0. Same thing over here. 0, of course, does equal 0. Now, if your answer is infinitely many solutions, then your equation is an identity. So you would put yes for this. All right, so go ahead and finish up your IXL. If you have any questions, let me know.